Next one. In this next section, we are going to look at the gravitational potential energy and the conversion of gravitational potential energy to kinetic energy. In this case, they assume that the frictional force is negligible. Okay, there's no frictional force, so you can actually, how to say, convert. They are convertible. How much kinetic energy you have, it can be converted to potential energy. On the other hand, if you have a lot of potential energy, you can convert it into kinetic energy. It's a direct conversion. Okay, right. Gravitational potential energy is defined as the mg times y. Y is the vertical distance, the vertical displacement, the change in the displacement. Okay, this is the y. And the energy, the unit for energy is joule. Okay. Next, the work done by gravity. Now, the work done by gravity is the distance, the difference in the gravitational energy. It is the uh, final potential energy minus the initial potential energy. Oh, because this energy is released, it's not the energy that you put inside, so that's why there's a negative sign in front. It is actually a negative work done. Now, the difference between negative work done and positive work done, right? So let me explain. Now, as you climb up a slope, or as you climb up a flight of steps, you climb up the stairs, you are actually putting in energy, right? So when you put in energy, this energy is conserved. So it is a positive energy. It's positive work done. When you fall down or when you slide down from a slope, you are not putting in any energy. You are actually releasing the potential energy. Now that is the reason why there's a negative sign in front. Negative means you are releasing the energy. You are not putting in the energy. You are drawing back the energy from the system. Okay, so that is why the negative in front. Whether it is energy that you put in or energy that you draw back from the system. Okay, right. Work done by non-conservative force. Non-conservative work done is equal to the change in kinetic energy plus the change in potential energy. Now, what they are trying to say is that if there is no friction or resistance, then the change is equal to the change in kinetic energy plus the change in gravitational potential energy, right? So they say if there's no friction, then you can equate them. So in other words, actually it's like this. Non-conservative work done is zero. When the non-conservative work done is zero, that means there's no frictional force. Then the change in potential energy is actually the change in kinetic energy. It means that how much is the loss in potential energy, that will be the gain in your kinetic energy. Or you can say how much is the loss in kinetic energy, that will be the gain in potential energy. So these two, they are transferable. You can transfer from potential to kinetic energy, or you can transfer from kinetic energy to potential energy, provided it is not it is conservative. The non-conservative is zero. That means it is conservative. Now, if the conservative is not zero, the non-conservative is not zero, that means if there is frictional force, then you cannot equate the change in kinetic energy with the change in potential energy. That means if If they tell you that there is friction, that means there is non-conservative work done, then you cannot equate the change in potential energy with the change in kinetic energy. Now, how to relate them are later examples. Examples, not this one, in the next file. Now, later examples, you're going to relate the potential energy to kinetic energy. Now, these few examples that I have left here, 5.4, right? This example 5.4, exercise 5.2, sorry, example 5.4 and exercise 5.4, they are actually telling you the potential energy is, the change in potential energy is always the same, right? The change in potential energy is always the same. It doesn't, it is independent of the reference point, the point that you consider to be zero potential. I will explain to you where, what they mean by the reference point, the zero potential energy, right? I explain to you, but you read this example first, example 5.4.
60 kg skier is at the top of the slope as shown in figure 5.14. At the initial point A, she's 10 meters vertically above point B. Setting the zero level for gravitational potential energy at B, find the gravitational potential energy of the system when the skier is at A and then at B. Finally, find the change in potential energy of the skier Earth system as the skier goes down from point A to point B. Repeat this problem with the zero level at point A. Repeat again with the zero level 2 meters higher than point B.
So now what they are trying to show you in this example is it is independent of the zero level. Where you fix the zero level to be, it doesn't matter, right? The change in potential energy is always the same. Now, in order to explain to you the reference point, the zero level, now let me ask you one question. Now you say that this point A is up the slope, this point B is at the bottom of the slope there. And if you say this is 10 meters, the distance here is 10 meters, right? Positive 10 meters. So which point is the zero level? You say that it is 10 meters. 10 meters from where? Where is the starting point? Can you tell me where is the starting point? We say that the height here is 10 meters. Okay, positive 10. Where is the reference point? Where is the starting point? Where is the zero point? Is it at B or is it at A? Or is it somewhere else?
Hmm.
10 meters. Where is this 10 meters measured? From where to where?
Point B to point A.
Yes, from point B to point A, correct. So that means our starting point is B. So this is our zero point, right? Oh, it cannot be somewhere below the B here, right? We don't know the distance here. So we cannot say that our starting point is, our zero level is somewhere below B. Because we know the distance, the vertical distance is 10, so B is the zero level. As you go higher and higher, it become more and more positive. Now let's say, for example, they have another point here, C, another point C. Okay, so and they say this point C is the zero level. This is the zero level. So how much is the point B? Point B is actually negative 2 meters below C. How much is the point A? Point A is actually 8 meters above, vertically above the point C. So in this case, we say that C is the zero level. If C is the zero level, then here will be 8, here will be negative 2. Now, if you say that B is the zero level, then here will be positive 10, right? So it depends on where you look at, which point you say is the zero level. Now, this problem is going to show us that irrespective of which point you choose as the zero level, the difference in potential energy is always the same. It doesn't matter where you choose to be the zero level, right? Okay, right. Question A. Setting the zero level for gravitational potential energy at B. So that means now we say this is zero. Okay. Question part A, we say that the zero level is here. Find the gravitational potential energy of this system when the skier is at A. The finally find the change in potential energy of the skier Earth system as it goes from A to B. Right. Okay. So now I'm going to quote this formula here. The potential energy is mgy. So the potential energy at A, you see I put a small letter A there to denote the potential energy at A. The potential energy at A is mgy. How much is the m? M is the mass, 60 kilogram. G is 9.8, and the distance is, the displacement is positive 10, because it is above B, so it's positive 10. If it is below our reference point, then it will be negative. So this one is positive 10. Right? So multiply together, oh, it is 5,880 joule. So that will be the answer to the first part here. The gravitational potential energy of this system at A. So this is the gravitational potential energy at A when we use B as the zero level. Okay, then find the change in potential energy. Now, if you want to find the change in potential energy when the skier move from A to B, that means from A drop down to B, how much is the change in potential energy? Okay, so the change in potential energy, you refer to this. The change in potential energy is the final potential energy minus the initial potential energy. The final potential energy at B is 0. You see here? Because the height is 0 already. At B here is 0 level. So the final potential energy at B is 0. So the final 0 minus the initial potential energy, which is 8,000, 5,880. So 0 minus 5,880, we have negative, the change in energy is negative 5,880. Now, again, I want to explain to you why it is negative. Negative means you are not putting an energy. Consider yourself to be the skier. Did you put in any energy to move from A to B? No. You slide down by itself. The person slide down by himself. So he's not putting in any energy. So we say that we are actually drawing energy from the system. So when you draw the energy from the potential energy from the system, it is negative. The work done is negative. That's why the change in potential energy is negative. Negative means you are not putting in energy. You are withdrawing energy from the system. Is this okay? Why is it negative here? Because you are not putting in energy.
Mm-hmm.
You are drawing energy from the system, right? To slide down the
Yes.
slope. You are not using an energy of your own. You are not input, you don't put in energy. There's no input. You're drawing energy from the system. This is negative here. But on the other hand, let's say if you climb up the slope, if you climb up the slope, that yes, you are putting energy, so it is a positive energy, right? So now you look at